I'm gonna be here. Okay.
Yeah. Okay, so I think we're live. Can you just double check there, Harold, if you don't
Yeah,
mind?
we are very much. Yes.
Okay, awesome. Okay, hello everyone, and welcome to Logic Apps Live for July 2023. My name is Kent Weare. I'm joined here with some colleagues, Harold, Aprana, and then Alex should be joining us here shortly as well. And Wagner is on vacation, so Wagner will be back for the next edition of this. And as a result, I'm the producer. So hopefully this isn't too bumpy of a ride because he usually does a good job of making this quite smooth. But we'll go ahead and do the best we can here. Let's go ahead and jump into an agenda. So today we'll talk a little bit about the Logic Apps community recap that we had last month. And then we have a special guest with us, Aprana, Seth, who's an engineer on the Logic Apps team. She has recently written a blog post around high throughput event processing. So we're going to have a brief chat with her on her perspectives and give you all some tips and tricks on sort of how you should think about this. Then we'll talk a little bit about custom code. We did announce this in the community day back in June, but I want to talk about a specific scenario related to that. And then next up, we'll talk a little bit about mainframe applications integration with Herald. And of course, we will have time for Q&A, so please do add your questions into chat and we will do our best to address them, whether that's in real time or at the end of the session itself. So first up, just a recap of Logic Apps Aviators Day. This was our community day back in June 22nd. First of all, thank you to all of our presenters, our speakers, and our attendees. We did have over 2,200 views. What was took place on that day has been recorded, and so here is the link that you can go ahead and use to access it. Basically, we've got all of the sessions broken down by speaker, and you will have the opportunity to go ahead and look into those. So any comments, likes are obviously welcome. Go ahead and add those into the videos themselves. But once again, thank you for participating in that. If you'd like to see more events like that, do let us know so that we can go ahead and try to create more of those in the future. All right. So, Aprana, maybe if you don't mind, just maybe giving a brief introduction about yourself, and then I've got a few questions for you, if you don't mind.
Hey everyone, this is Aparna. I have been working with Logic Apps from past 7 years. That's my all time with Microsoft, and I love being here and all the innovation we are doing.
Awesome. And thank you for joining us today. We love bringing the engineers on, the people that are building the products themselves. So really appreciate you joining us here today. So you recently posted a blog post about high throughput event processing. We've got the short link there. And can you explain like what was the nature of the blog post and what were you looking to achieve by writing the blog post?
Yeah, so this blog post actually talks about the sustained event processing system, how we can achieve a sustained throughput from event hubs. Basically, what we are showcasing is the usage of different Azure integration services within Logic Apps. And the key initiator here is looking at a high throughput scenario wherein events are being pushed from the publisher into the event hub, and then the Logic Apps basically consumes those events, and then within the Logic App workflow, you can have several type of actions which you are using to process the workflow, like using variables, conditions, scopes, and calling Azure functions, and then probably calling another event hub wherein you save the status status of those events being processed. In this blog post, essentially, we talk about two different scenarios. One is the high throughput event processing logic app, wherein the events are processed by the single logic app. And then another scenario which we handled was when you want to handle or control the throttling limits onto your downstream services so that we are not overwhelming them. So the key initiator here was that we were working with a customer in the insurance domain, wherein they had high throughput scenario, looking at 250 to 300K actions executions per minute. And we did some perf testing for them. So we when they were doing when they were initiating the migration from ICE to Logic App Standard, since we had that data, so we thought that it's good to share all this information with the forum as well, so that other customers can get best out of it.
Yeah, and thank you for putting together this blog post, because this type of information is highly sought after. So you did mention throttling is one of the scenarios that you did test. How should customers think about throttling when it comes to designing solutions? And I suspect that there's sort of a few different ways in which throttling gets implemented. Can you share more about that with us?
Yeah, so even in the second screenshot which you look at, that is about the throttling, wherein we throttle. So essentially, in several cases wherein you are using downstream services, there are limits on the downstream services that they can process only some data. Otherwise, we might end up overwhelming them. So we need to have some sort of controlling mechanism or some knobs pulled on to the logic apps, since we are using the functions trigger, and event hub triggers is really fast enough to load all the events in the event hub very fast at par, eventually, like the way you would be pushing the events. So that could cause a problem on the downstream services and overwhelm them. So if you want to control all that, so concurrency is something which you can use on the workflow. So what we did in this scenario was we divided. Okay, let me take a step back and talk about how we did the high throughput scenario. Therein only one logic app is there, which is listening from the event hub and processing every event which it is using, basically by either having some scopes or looking at the JSON payload which is uploaded, and then doing some validation. For that, you might be calling to a function app, and then certain other if else conditions to check the type of the payload and do something else. Basically, all the processing associated with it resides in that logic app. And once you are done processing it, you send it to another event hub. Or if at all it failed for some reason, you send it to another failed event hub, which wherein you can look up those events later and then process them later. For throttling, how you can achieve that is that divide your workflow into two parts. One is the parent one. The parent one is the consumer from the event hub that holds everything within it, and then define the child workflows and invoking those child workflows from the parent workflow based upon a switch criteria, maybe some random number initialization from 1 to 10, and then pushing that data to the child workflows, and which would have concurrency knobs established on those workflows. Based upon that, it controls how much data gets pushed to the downstream services, so we don't overwhelm them, and everything goes smooth with them.
Got you. And, just in terms of the results, here on the right-hand side of the screen, we can see the sort of the different outcomes, in the high throughput events processing that represents like the single logic app. And then we've got the logic app with throttling limits on downstream services. So what was the impact that throttling did have on your tests?
Yeah, so throttling, of course, we want to slow down here, right? Because we don't want to overwhelm the downstream services. So the throughput which you will get with throttling and in place would be definitely lesser than how you got with the high throughput scenario, wherein the single logic app is taking everything from event hub and processing them like right away. There we were able to process all those events, like 10K events were pushed per minute at a sustained rate, and we were able to process them right away. Obviously, the test which we ran had only like test hello world kind of the scenario. It is not like actual bigger objects or events which we were trying to test here. But just to give you a benchmark here, if you have those kind of workflows wherein like just a hello world, obviously it is not the general scenario wherein customers would be using, but even the functions also which we were calling just hello world, but with that we were able to process all the events right away, or at par when it is high throughput scenario and single logic app is looking at processing all the events from event hub. But in the other case wherein we had the throttling, we wanted to control the throttling limits for our downstream services. There we saw obviously there was a lag, and it took a while for all the completion of the events or the runs to complete after even the test run was completed.
Got you. And this is something where we do oftentimes get asked about, like, throughput. And so I think these are, even though the messages might have been smaller, it is somewhat representative. And so customers can get like a sense of like what's possible with
Right.
these numbers.
Right. And one thing which I wanted to call out here for both the scenarios, like when we are talking about high throughput scenarios, you can't use just a single storage account like what we have by default in Logic App standard. So the recommendation there would be to use multiple storage accounts. And I think there is another post, blog post, which talks about how you can set several storage accounts within a Logic App. That will help. Otherwise, we will end up into storage throttling and then retries. That will cause all the problems. So if you are looking at a high throughput scenario, uh, do ensure that you're using multiple storage accounts.
Yeah, and so that kind of leads into my last question. So, what are some key takeaways for customers when building the high throughput solution? So you did mention basically multiple storage accounts. Are there any other sort of considerations that customers should think about? Perhaps like retry policies, things of that nature?
Yes, for the high throughputs and for the throttling scenarios, since we were using the child workflows, so we want to ensure that everything gets passed on to from parent to the child, and without throttling that, because at the end of the day, the child will also start throttling that I can't go beyond this, and then it would throttle parent. So for those things, you should add the retry configuration on the invoke operation action, which we have talked about in the blog, how you can do that.
Excellent. Now, you did mention some resources. Did you want to talk a little bit about some of the resources that engineering has recently put together?
Yeah, so there are a couple of things which have been put together by Rohita from our team. He is one of the engineering lead in Logic Apps team. One important thing about what I talked about already, how you can use several storage account. That is the second one here in the screenshot, scaling Logic Apps for high throughput scenario. That is our recommendation. Whenever you see that high throughput is something which you're looking at, see that you can add more storage account, and this blog post talks about how you can set up those storage accounts. And another such test we did for high throughput batch data processing system, wherein we didn't push a sustained load like we did for the event hub scenario, which the blog post we talked about here. This blog post also talks about how you can process the batched data for high throughput scenarios.
Excellent. Now we've got a few questions. Are you game for a few questions here, Aprana?
Yeah.
Okay, so from Michael Stevenson, his first question, it should show up on the screen. I don't know if it did or not. So his first question was, I'd be interested to learn about the parent to child workflow call load, how it was configured.
Yeah, so maximum concurrency was set to 100. So that is why I said, because since at a time on the child workflow, so from one parent there were like 10 workflows were set for child workflows, and every workflow, child workflow had a concurrency of 100 set to it. That is why I mentioned that if you set a concurrency on the child workflow, it is required that you should set a retry, which is like the exponential retry, because default retry might not work in this case. The reason being the child would be processing that event, and that could take a while to process, and we can push new runs only once that concurrency limits are met. Like for example, if you have 100 concurrency and one of the run completes, then only we will push another run from parent to child, and that will be dispatched on the child workflow. So adding the retry would help getting that through uh, too many requests problem from the child, wherein child workflow will stop accepting new requests.
Okay, then there's another one here. Let me just put that on screen. Once again from Michael. We tried this and we found that we were getting issues that the workflow queue was too long, if I remember right. It was a while ago. So we tried to push the throttling back to service bus. Any sort of thoughts on that?
I'm not sure if I follow what is the workflow queue being talked about here. And if we are talking about service bus scenario, this might not will work with service bus. The reason for that is because here parent is holding on to things, right? And then it can hold for a longer period also. But if we do same for service bus messages, the lock duration will be lost from parent, and we will not be able to complete or process or complete the processing of that message, rather abandon or do anything about that.
Okay. And then there was one more. If we have scaling, hold on a sec. If we have elastic scaling, can we limit that one app scales out lots, but one app doesn't scale out to keep throttled so that they can share the same plan? I think there might be some config settings for this.
Elastic scaling, can we limit the one app scales out lots? If you're using the same app service plan, I think you can do that, but we have to check back on this. I don't think there is a config, uh, but different apps, I think we have to double click on this. I'm not so sure.
Sure. Yeah. So Mike, we can follow up after on that one. Okay. Well, thanks, Aprana, for sharing more. We've got the links here for folks to go ahead and check out. And then, are you going to stick around for some more questions later? Okay, great.
Yeah, I'll be here.
All right, cool. So we'll now just jump on to the next part of the agenda. And here, let me just do one thing here. We'll talk about custom code extensibility. So this was something that we had announced in public preview back during the Logic Apps Community Day, June 22nd. And so just to recap what we discussed, we now provide the ability to call .NET Framework code from a built-in action found in Azure Logic Apps Standard. So that's what you're seeing right here. And one of the benefits of this is that we allow you to now locally debug both your workflows and code in the same VS Code solution. And we've got a short demo that we'll show. And as part of that demo, you're going to see that we've got support for dynamic schema for both inputs and outputs. So much like you would expect with any other action that you have, we're going to go ahead and support that with custom code, which is pretty cool. So as you basically write your methods and you have your basically inputs and outputs defined, the Logic Apps designer is going to understand those. Now, one of the benefits of using this approach is that you can run code in the same workflow service plan as your workflows. You don't need a separate plan. As a result, you don't have a separate service area that you need to secure. And as a result, we can reduce some latency because your traffic is not leaving the box between your workflow and your custom code. And so one of the drivers for this feature is really around unlocking BizTalk migration scenarios. And so this is the main driver for .NET Framework. This is a common question, is like, when are you going to support other languages, or do you support other languages? We will support other languages. We'd love to hear what you're looking for. Is that just .NET Core? Is that PowerShell, is that Python, is that something else? But we will GA .NET Framework first. Our model is rather extensible. We will have the ability to add additional languages, but we were driving or prioritizing BizTalk workflows itself. And so it's one of those things where customers thus far have been pretty excited about this feature, and we're looking forward to more people onboarding. Now, in terms of what are some of the things or use cases for .NET Framework custom code? So custom business logic, naturally we've all been there, especially if you have some more complex integrations or interfaces you need to build. Sometimes a visual designer may not scale. Maybe you have too many business rules. It's easier to code them. It's easier to debug them. It's easier to test them if you do have some code that's doing that. I think calculations is another sweet spot for this. Obviously, we've got Logic Apps workflow definition languages where we've got those functions that allow you to do that. Those can be difficult to maintain, difficult to debug, especially if they're complex. So being able to do that in code where it's more testable is naturally of interest for folks. We also have custom parsing. Perhaps you want to make sure value A, value A, B, and C are all, of a certain type or different dependencies. That's something that lends itself to custom code. Data validation and simple transformations, another opportunity here. Actually, naturally we do have the data mapper that's in public preview. We also have the existing support for XSLT files generated from BizTalk. But for some scenarios, you may want to do that in code, and being able to do that closer to your workflow might be advantageous for you. And then also we've got, if we want to call an outbound API and we need to do some message shaping, maybe we need to do some sort of aggregation, doing custom code to do that might be useful for you as well. And then a couple items that I just added based on some recent customer conversations, encryption, decryption. Naturally, we do have encryption in our platform, basically at rest and also in transit. But in this case, someone was looking to do PGP, and being able to use a .NET library to go ahead and do that makes sense. Also, you might need to do some sort of compression. We've all kind of been there with BizTalk needing to do zip files or gzip or things like that, and you might have some .NET assemblies that you need to do to use to go ahead and perform those operations as well. So these are some potential scenarios where you could go ahead and use the custom code. Now, one of the scenarios I wanted to talk a little bit about was what if you've got some existing libraries that you're using in BizTalk, and now you want to go ahead and use them inside of Logic Apps. So what I've got here is a picture of a BizTalk solution. I've got a assembly here called contoso.hcm.helper. What it's doing isn't overly complex or interesting, but just to show you that this does work. These are the static class and the methods that are part of this assembly. Now, I want to be able to go ahead and use this inside of Logic Apps. And so what do I need to do? Well, I think the first thing you need to do is, go ahead and copy that file into a folder. In this case, it's a bin folder. And then update your CS proj file with either an absolute path or a relative path. And then, basically your C# project will be able to go ahead and find that specific assembly. Now, if you're using NuGet, great. That will also work. You would just go ahead and add a package reference. So here we've got references to other dependencies that are first party, but you would go ahead and add a reference to your NuGet package. Then what's going to happen, and you don't need to do any additional work here, is when you go ahead and compile your code, we're going to go ahead and bin place all of the dependencies related to your custom code, including this additional assembly, and bin place it into the Logic Apps folder. And Logic Apps is going to be very specific about where these assemblies need to be located. They need to be located in the lib custom net472 folder. So that's where we're going to be able to look for them. And then the designer will be able to find them. So here I've recorded a short demo, and I'm just going to remove myself from the stream. So this is a little bit bigger. And what we've got here is our new project structure where we've got a workspace file, we've got a functions project, and we've got a Logic Apps project. Now, as part of that folder structure, I've gone ahead and copied my assembly into the bin folder. I've then gone ahead and added a relative reference to that folder in my CS proj file so that it knows where to find this specific assembly. If I go into the basically the class that I'm using for my custom code, I've added a reference to this assembly. And then I've got two functions that are being called here. The first one is just a sample function that you get when you provision the custom code solution. We've got a unique function name, and you can see that we're using the workflow action trigger, which is our entry point. And then we've got our various inputs and outputs. Now we can add another function by just simply copying and pasting the other one, making sure we've got a unique function name and a method name. And then we can go ahead and add another function. Now we could add another class file as well. It doesn't have to be in a single class file naturally. So we treat our code separate. We want to make sure that the Logic App project is only dealing with compiled assemblies. So here we're going to go ahead and build our code project, our function project, and it's going to then bin place all of the dependencies in our Logic Apps project. So we've got our lib folder here, net 472. So there's that Contoso HCM and then our custom code. And then we've got the two methods. Now, this is pretty important where this is what's going to determine our dynamic schema. When we use our code action, it's going to use these files to understand what are the inputs and what are the outputs that we can expect to use or need to provide in the case of inputs in our workflow itself. So let's go ahead and take a look at our workflow designer. Here's where we're going to have our code action. So I'm just going to delete this one and re-add it just so you can see that experience. So we'll go ahead and search. This is a built-in action. And so go ahead and just type in local, and you'll see the local function. Then we have this drop-down. Because we've got two functions, we can now go ahead and select the function we want. And then it will dynamically indicate what are the parameters that we need to go ahead and provide. So I'm just going to hard code a value here, but I could use a value from a trigger or any other dynamic output. And let's go ahead and debug this. So we're going to set breakpoints in our workflow file and our code file. And then we're going to enable the debugger for the Logic Apps and enable the debugger for the code itself. So that's what's going on here. To go ahead and call this, we're going to load the overview page for the workflow. And we can simply just go ahead and click Run Trigger because we're not providing any inputs. And we'll see our breakpoints are now hit. So we can use sort of the standard step in, step out, F10, F5 capabilities. And we'll see as we jump into our code, we do have the local window and we can see the exact values as we're basically debugging our code. Once we've completed the execution, we'll go ahead and see our run history, and we can see the inputs and outputs. And so that's essentially the demo. So I see we do have a question here from BJ, just related to any plans to support Logic App Standard and Function App sharing the same app service plan. That's kind of what this is. Under the hood, we are deploying a function. And so there's sort of no need for us to really do this because you now have the same capabilities by using this specific feature. So you would go ahead and write your function code. Basically, you then can have it within your project and use the same app service plan. So that's it. If there's other questions, feel free to add them in the chat and we will address them later on in the demo itself. Let's just jump ahead here and we'll hand it over to Harold. Harold, do you want me to just drive the screen?
Yeah,
here?
Please. Do you mind doing
Sure.
that? Thank you. Okay, so let's get started, and thank you, Ken and Aprana. So we'll talk a little bit about the CICS and IMS connectors. CICS and IMS are mainframe applications or platforms where you can build applications for mission critical workloads, credit cards, mortgages, ATMs, airline systems, etc. Right? So they have been available for about 70 years, and they are still available, and they are still running mission critical systems. So then, as a part of our mission critical initiative to move more workloads to Azure Logic Apps and enable more scenarios, that's how we are targeting all of these mainframe integration and modernization technologies that we've been showcasing in other series as well for mission critical systems. For us to use the CICS and IMS connectors who are currently in preview, Visual Studio, you start with Visual Studio. With Visual Studio, what's going to happen is that you have to create a definition for these programs that you are going to be invoking from the host, from the mainframe. Can I quickly share, Ken, my desktop? Is that possible? Do you know? Let me share. Let me see if I can share my screen. Yeah. Okay. So hopefully can. All right, thank you. So, so this process starts with the definition of a program that I have to interact against. So for instance, I have a definition of a CICS program, a COBOL program, and I need to integrate with this program. So then what I do is I import this program into a project, and I will end up having a structure like this, where you will have the ability to, as I said, import this host definition as a COBOL program and then convert it into what it will look like a map, right? So this object will have this an interface, a method, input parameters, output parameters. This is a fairly simple one, actually, folks, because you can have, you know, in mainframe systems, it's not atypical that you have programs that receive more than 100 fields of input and return something similar. So that's why using tools like this becomes very relevant, you know, in your integration journey. So with that said, so once I have this definition, so then what I do is I get into uploading this object into the logic app. But before getting to that part, I want to add more information on why is it that this is relevant for your journey. Kent, do you mind going? Let me stop sharing. Do you mind going back to the slide, please? Thank you. So in the case of CICS and IMS, these are systems that have been around for since 1966 and 68, I think, both of them. And let me get back to the content so I can explain what this is about, right? Let's see. Fantastic. So then, so you have the ability to upload these HIDX files or these files that have the map definition for the COBOL programs into the logic app per se, right? So then there are actions that are available. Do you mind going to the next slide, please? Thank you. The way how we call a CICS program is that we have a definition, as I said, of the program, and then we enable, we use the Logic Apps CICS connector, and it has different ways to integrate with a mainframe. We can use HTTP, so we can invoke HTTP services, web services that are available from the host, or we can use TCP/IP. The difference between one or the other, it's a customer choice, right? Some customers, they decide that it's better for them to just invoke HTTP web services because they are prepared to do so and they have set up their mainframe for such. But while others, they prefer not to do that and they prefer just to have TCP/IP direct access to it. In terms of models, we have a couple of models. One model is that use the COM areas, that basically are the structures where you can pass information across different applications in the mainframe, inside the mainframe or outside the mainframe. And you have a model where you don't need to use the COM area, but you have to specify everything on the program, and there is not an actual limit on the amount of data that you can pass. Now, with that said, there is another alternative to connect, but that is unavailable with Logic Apps at the moment, which is using Host Integration Server if you need to use SNA communications. If your mainframe is set up for SNA or SNA over IP, RSNA over IP these days. So then you will require host integration server to extend this this picture that you have here. Do you mind hitting next, please, Ken? Thank you. And the same applies for an IMS program. The main difference with an IMS program is that when we call an IMS program in a mainframe, we are interacting with a system called IMS Connect. That has a listener that is prepared to handle these integration scenarios via message queue. So internally, this is a method that has been optimized for uh, uh, high performance and low latency scenarios. So you have these both alternatives, and with those alternatives, so then you can interact with these legacy systems. Do you mind going next? I think the next one is the demo, so I'll just share my desktop. Yes, so let me share my desktop real quick. Okay, share screen. Now, hopefully you see what I have. All right, thank you. So then back to the definition, I was speaking about having COBOL programs, and then once these COBOL programs are available, we convert them into these HIDX files that represent the structure of the COBOL program. In this case, I have an IMS Connect program, a COBOL program that is running in IMS, and I have another COBOL program that is running on CICS. So what I'm going to do is I'm going to go to our workflow and in Logic Apps. One of the things that I want to call out first for when you need to integrate with these on-premises systems is that you need to leverage the VNet integration feature, because otherwise, you know, you have to provide a secure access to your mainframe because it's part of your data center, right? So then you enable, by enabling the VNet integration, so you are able to use a peer network in ExpressRoute in this case that will allow to encrypt the traffic and also to provide the level of security that you need for these scenarios. So the other thing that I wanted to show you is that these HIDX files that I created with Visual Studio, they are uploaded into the maps artifacts. So I have a number of them here, right? So then when I go to the workflow to create a workflow, I am able to just use them because they will be available for the workflow to be used, right? So in any workflow that I create in this Logic app, I have created this fairly simple workflow that has interaction with a number of systems inside a mainframe. So we can do a screen integration, host files integration, then IMS and CICS, which are the ones that we are going to take a quick look at, and then MQ systems as well. So the way how I'm going to do this, like if I go to the IMS program, you will see that I have here an HIDX definition, the method name that I created that I had available in Visual Studio as well, and then parameters, input parameters, and then I have a connection definition. The way to create a connection is you will have to enter a number of fields that for which you will have to talk to your mainframe specialist. He will have to provide you a number of variables and parameters that you will have to enter here, and you will have to have at least a port open in the mainframe system to interact with the IMS Connect system. And the same for CICS, right? So if I were to do something similar with CICS, I will have to use an HIDX file that was previously uploaded into the system, into the maps artifacts. And then also I'll have to set up a connection here. And this connection will have the variations that I just showed you in the previous diagram, right? You saw that we have TCP IP options and HTTP options. So this is exactly what I meant, right? So you pick here the model that you plan to use to connect to the CICS system and program, right? And transaction, and then you select it, and then you have your connection defined. Now, something important to mention is some customers, or well, you may have the question, why is it that I just don't call a web service from the host? It's because, as I said, so some customers, they decide not to expose web services because their systems are just not ready for it, or because it's just too much work for them to do, right? So yet we have the alternative to do it using this connector. Now, the other question is, why don't I just use another connector like the HTTP connector to call these programs, and then I don't require the CICS connector. You saw the HIDX file, right? So I just had a few parameters on it, but it can have 100 input parameters, and it can have refines, and it can have nested structures. So then you don't really manipulate all of those that complexity in your workflow. So that's the reason why we abstract that complexity by having the HIDX files that you can create with Visual Studio. Okay, so once you have completed all of the connection information in this environment, so then what you do is just execute the workflow, right? So in this case, this workflow takes a host file, which is a binary file, reads the host file, and then what it's going to do is it's going to parse it, right? So I parse it here, right, in parallel, but I'm not necessarily reading that information for the IMS and CICS transactions to be kicked off, right? So I go here, and then I upload the file here. This is a binary data set that I created in the host. I upload it, and then I go to the workflow, and then it should be running. Let's see if this is the one. No, it's running now, right? There is something that I want to call out real quick when we get into when this workflow is complete, is that if I go to the execution of this workflow, to the details of the execution of this workflow, you will see that a number of these actions have completed already, right? So the IMS and CICS, they took 0.1 and 0.2 seconds to be executed. So what happened under these 0.2 seconds is that, or 0.1 second, is that this workflow interacted with the mainframe, with the IMS system, with the CICS system, and yeah, it hasn't finished this one. I'm going to explain why, right? And for the other case, like it was 0.0 seconds for MQ, and the reason why this was this is the CICS and IMS connectors were optimized for low bandwidth networks and very low performance machines. So this technology has been available for almost 30 years. So the only thing that we've done over the last 5 years is just to move them. We've moved this technology into Logic Apps, of course, improved it, right? And then that's available for our customers to use. One last thing, this one took longer because this one executes navigation plans in 3270. So what it does, it goes through a sequence of screens, and then you have to define a navigation plan for these green screens to get it done. But anyway, so I don't want to deviate from the IMS and CICS system. So if I go to the details of CICS, the output is 777.12, which is what the COBOL copybook was returning, right? So if I go to the IMS get balance, somewhere it's moving 777.12, right? Was it this or the other one? Yeah, I think it was the other file. But anyway, so it was returning that data, hard-coded data, right? And this is exactly how it looks on the mainframe. So this is a fairly simple operation, right? So there is really not a lot of complexity on the COBOL program, but in any case, these are programs that are fairly they execute fairly fast in the host, right? And with that, I'm going to wrap up and give it over to you, Kent. Thank you.
Here. Let's see. That's not the view I want. Okay, that looks better. Okay, so we can. I'll put up the first one here. So deploying workflows through Terraform or ARM templates to existing Logic App standard. The template should create a connection to service bus. Will this restart the Logic App And then I assume the next question here is like, what will happen to the workflow that could be in flight when it gets restarted? Aprana, did you want to take this one, or do you have anything to add here? I can give part of the answer, but if you had anything, I'll defer to you.
I don't have much idea about the
Okay,
Terraform templates,
sure.
to be honest.
Gotcha. So whenever you do make a change to the Logic app, whether that's in the portal or whether that's through like some other process, CICD or ARM templates, it will force a restart of the application itself. So this is where I think if you've got sensitive workloads, you probably want to plan your deployments or also implement patterns to avoid so things like peak lock is a way to avoid anything that's in flight to from it being lost. I don't know if anyone else has anything to add there. I'm not Wagner would probably be the best person to answer this. Unfortunately, he's not here with us, but anything else folks want to add to that one?
So from service bus perspective, like you said, if you use the peak lock, that would help. Let's say the restart happened after you read the message, right? So we were not able to even complete or abandon the message or perform any action we wanted to do on the message. What will happen is that that message lock will be lost after the set lock duration on the entity in service bus. Once that is done, that message will reappear on the service bus queue or topic, and then it will be reprocessed. Only thing will be there are chances that it can get processed twice in this case.
Gotcha. Yeah, that's kind of how I was thinking about it as well. So it's one of those things where, the peak lock might help here. I think the other thing is if you can plan it, you could also disable any sort of logic apps before you do a deployment, and then you'll, especially if you're using service bus, where those messages will queue up there, and then you can do your deployment without sort of concerns about any sort of messages being lost. The next one is an interesting one, and I don't know if we've got a good answer today for this, but any thoughts about creating dynamic connections to service bus inside the workflow, not the settings in the logic app, but a parameter of the workflow to connect to a service bus based on a condition? So I feel like this is kind of the need for like dynamic connection allocation. We've heard about this requirement for like SFTP locations as well, where maybe based upon some property you load the connection just in time within an action, as opposed to having to like statically have a bunch of if else statements. So this isn't something that I'm aware of that's being worked on. I do know that this is in our backlog. I'm not sure if it's something that we're actively working on. I think this would be another question for Wagner, unfortunately. But yeah, this is something that we are aware of. It is on our radar, but I'm not aware of any active work in this area. And so yeah, Mike had a comment. I guess if I have a dehydrated workflow on the restart, it would continue on the new version of the workflow. I think in consumption, it would continue on the version it started on. Yeah, like I think that's a fair assumption. That's my understanding as well. In consumption, there is that notion of history, and you do have kind of the version of the workflow pinned to the execution. With standard, it's more of like the app model, right? Where you've got basically the workflows that would be sort of like currently being available from that perspective.
I think as far as I understand, the version gets again pinned to the runs, even in Logic App Standard, but we can get this confirmation.
Okay.
So the runs which are associated with the particular version, they will run with that version only.
Gotcha.
But we can
Okay.
get a confirmation on that.
Okay, next question. Is it possible to call on-premise web service with Kerberos authentication, Logic App standard hosted in an ACE? Harold, is this something you're familiar with? I know you've been doing some
I've seen that question
investigation around this
before.
recently.
I've seen that question before, but no, it is not as far as. I mean, I think this is not. I'll double check. Okay, I think it's with Azure AD, but I'll double check and then I'll post it in the comments if I find something else. Okay.
Yeah, sounds good. And I think it's, definitely not native, right? Like Kerberos isn't sort of native in the cloud, right? So that's where like you might have to do a proxy component or something like that on-prem to sort of work through that. Because like they're, with us being a cloud-based service, we're not going to be able to sort of create our own Kerberos tickets for your local AD provider as well.
Right.
Yeah, I think Mike has a question here. I think he's on the right path here.
I think it's the answer is using the gateway, right? Because the gateway will probably open you the door for
Any other questions folks have? The other thing I'd put out there, are there any topics that folks are interested in us covering in an upcoming Logic Apps Live? That would be also information that would be quite helpful for us as well. All right. Okay, we've got another question here. We use batch triggers accumulating messages based on count or time schedule. If a new workflow in the same Logic app gets created, will running one lose messages? How to stop batching? So I'm obviously familiar with the batch feature. What's I'm not sure about is the new workflow. Like, is there multiple workflows trying to service the same batch? That's what I'm not sure of. But the batch itself is an intermediary where there's some storage where that information's being stored. So I would expect that information to be persisted because that is some storage where we will place those messages while they're accumulating, and then we've got the evaluation.
I'm not sure if this is associated with the restart that would happen for the host when you add a new workflow. If that's the case, and we are looking at what was batched for the other workflow, will that cause any issues to that? But it will not if it is related to the restart. But I don't understand that appropriately when the new workflow gets added. Is it for that to read from batch, or is it associated with restart?
Okay. All right. Well, I think unless there's any additional questions, we'll probably wrap it there. But thanks everyone for tuning in. And if there's any sort of topics you'd like to see in future events, please let us know, and we'll do our best to accommodate. All right.
Awesome.
Thank you, everyone.
Thank you.